Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan mo po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good morning, grade 10 students of the vibrant city of Valenzuela. Welcome to the 5th module of the 2nd quarter here in our virtual hall, Valenzuela Live in Mathematics. Please prepare your learning packets, notebook, and ballpen. Be physically and mentally ready as we venture and dig deeper into the world of circles. At the end of today's session, you are expected to illustrate secants, tangents, segments, and sectors of a circle. Furthermore, we will be computing for the area of segments and sectors of a circle. Well, circle is more than a geometric figure. It has far greater context. Are you familiar with the movie The Lion King? A lot of Disney fans can surely relate to this movie. One of the songs used in the movie is entitled Circle of Life. Let us look at the lyrics of the chorus. I'm sorry I cannot play it due to some copyright issues, but let us try to appreciate its meaning. It's the circle of life, and it moves us all, through despair and hope, through faith and love, till we find our place on the path unwinding, in the circle of life. Well, circle is used in the song not as a geometric figure, but as a symbol of the never-ending cycle of life, that we should appreciate, enjoy, and take the wonders of the world. It's actually a symbol of hope and new beginnings. It's a reminder of the complications and victories throughout one's lifetime, and that we should really seize all the moment embedded in this great circle. So, let us enjoy this discussion that we are having at the moment. Last sessions, you had an in-depth discussion of the first few terms related to the circle. These are chords, arcs, central angle, and inscribed angle. And of course, some theorems related to these. For today, we will be illustrating other parts of the circle. But before that, let us have a short activity entitled Draw Me. Let us see if you can follow the given instructions or directions and be able to draw the needed figure. For this part, you will be needing any paper and a pen. Again, you will be needing any paper and a pen. Compass and ruler can also be used for easier and more accurate construction. Are you ready? Let's begin. First part, you need to draw a circle. Again, you need to draw a circle. Make sure that it is big enough so that you can still draw lines inside. Are you done? All right. Step number 2. Draw a line that intersects the circle in exactly one point. Again, draw a line that intersects the circle in exactly one point. I hope you are done. Next, draw another line. This time, it should intersect the circle at exactly 2 points. Again, you need to draw another line. This time, it should intersect the circle at exactly 2 points. I hope you're doing good. Last, draw 2 radii that does not form a diameter. Again, draw 2 radii that does not form a diameter. Are you done? Were you able to do it? Can you comment a picture of your work on the comment section? I would appreciate to see all your lovely works. So while I'm waiting for your outputs, let us try to construct the figure that is being represented. We have the circle, as you can see on the screen. Draw a line that intersects it at exactly 1 point. So you have that yellow line. We draw another line that intersects it at exactly 2 points. You have the red line. And finally, we draw two radii that does not form a diameter. Now, what parts of the circle did we make? You are right. Our main focus for today would be on these 4 parts that you can see on the screen, as we are going to illustrate tangent, secant, sector, and segment of a circle. Let us start. On the next slides, I will be showing you pictures of cars that I know you wish you own. Really nice cars, huh? Now, what part of the car is circular? It's the wheels, right? We are only talking about the circular part and not the whole wheel, which is actually a plane. Now focus your attention on the road. Again, focus your attention on the road. Does the road touch the whole wheel? No. Ideally speaking, it only touches 1 point at a time. Therefore, if the wheel is the circle, what term related to circle would the road be? Again, if the wheel is the circle, what term related to circle would the road be? Comment your answers. All right. If you have written or if you've been thinking about tangents, you are correct. The road is tangent to the wheel. Let us look at these 3 cases that we have on the screen. For case number 1, line L and circle P have no point in common. And as you can see, X is an exterior point. For case number 2, line L and circle P share a common point, which is X. And so, X is on circle P. For case number 3, line L and circle P share 2 common points, which are A and B. And X here is an interior point. Looking at the illustration and description for each case, which among the 3 would illustrate a tangent? So you may comment your answers. Last 5 seconds. You are right. That is case number 2. As you can see in the figure, point X is on circle P. Formally, we define tangent as a line, a segment, or a ray that intersects a circle at exactly 1 point. If you can remember, for case 1, the line does not touch the circle, while for case number 3, the line touches the circle at exactly 2 points. Clearly, those 2 cases would not fit this definition. Let me reiterate that a tangent intersects a circle at exactly 1 point. That point, in this figure, it's X, is called the point of tangency. Look at this athlete in the sports of discus throw. He's making a circular movement to gain momentum so that he can throw the discus in a far range. When he gained enough momentum, he's going to let go of the discus and it will be tangent to the circle that he formed while gaining momentum. This again illustrates the concept of tangent. I hope that everything is clear so far. Moving forward, in the next slides, let us travel across places where we can see pictures of bridges. We can actually construct circles here for the sake of visualization. The support above the bridge can be a part of the circumference of the circle. If that is the case, what part of the circle is the actual passageway of the bridge? Allow me to highlight those passageways again. Again, what part of the circle is the actual passageway of the bridge? You may comment your answers. All right, time's up. Those are secants. I know by now you can define secants on your own. But let's go back to these three cases, the three cases that we have earlier. Now, which case would illustrate a secant? Comment your answers. Is it case 1, case 2, or case 3? You are definitely correct. Great. Case 3 illustrates a secant. Line L and circle P share two common points, which are A and B. A secant is a line, a segment, or a ray that intersects a circle at exactly 2 points. Let us take a look at this busy highway. We can actually see a secant here. Another picture is this highway in Thailand. So you can also see a secant here. Now let us take a look at this unsliced pizza. There are actually two ways in which you can cut the pizza: the usual cut and the barcada cut. These two cuts can illustrate the next two parts of the circle that we will be talking about. Let's first have the usual cut. The part that is shown is called sector, the pizza slice. A sector is a region bounded by two radii and an arc. So we are talking about the inside portion since the definition calls for the region. Our boundaries are two radii and an arc. Another cut is like this. In this case, we formed a segment of a circle. That can be produced if we use the barcada cut for the pizza. A segment is a region enclosed by a chord and an arc. In this picture, we can actually see a lot of segments. Just look for a chord or find a chord and an arc. Again, let me emphasize that sector and segment are regions. The boundaries for sector are two radii and an arc, while for segment, we have a chord and an arc. Let us look at this logo, or let us use this logo of Project Watch to illustrate sectors and segments. Project Watch is an initiative launched by the Department of Education and is advocated by my mother institution, Mapulang Lupa National High School. Project Watch stands for We Advocate Time Consciousness and Honesty. Let us be watch advocates in this modern world. Going back to the logo, if we use the minute hand and the hour hand of the clock, we can form this region. What part of the circle did we form? You may comment your answers. Again, what part of the circle did we form? If you have answered sector, excellent. As you can see, the region is enclosed by two radii and an arc. Now, how about if we use the seconds hand, the red one? I'll extend it. What part of the circle did we form? You may comment your answers. Again, what part of the circle did we form now? Right, time's up. That can be a segment or a sector. Why? Take note that the boundaries are a diameter and an arc. Take note that the diameter is formed by two radii, so it can be a sector. Also, the diameter is your longest chord, so it can be a segment. At this point, let us move on to the areas of a sector and a segment. Let us consider this circle. Can you recall the formula for the area of the circle? We have the area is equal to pi r squared. Now, what if we divide the circle by drawing a diameter? What would be the area of the shaded region? That is half the area of the whole circle, or 1/2 pi r squared. What if we further divide the circle by drawing two diameters? What would be the area of the shaded part? That is 1/4 pi r squared, or 1/4 the area of the whole circle. What if we have this shaded region? How are we going to get its area? Let's analyze the first two cases so that we can derive a formula to find the area of the third circle. Let us get the angle measure for the shaded part of the first two circles. Circle 1 has 180 degrees, while circle 2 has 90 degrees. This angle measures has something to do with the area of the shaded part. The total degree measure for a circle is 360 degrees. So for circle 1, we have 180 over 360 pi r squared. Simplifying that, we'll go back to this formula, which is 1/2 pi r squared. For the second circle, we have 90 over 360 pi r squared. Simplifying would go back to our earlier formula. Thus, in order to get the area for circle number 3, we need to get the angle measure for the shaded part. Let that be theta. So our formula would be theta over 360 pi r squared. This is now our formula for the area of a sector when theta is in degrees. By the way, theta here is your sector angle. Let me repeat that. Theta is used as a sector angle. Now, if theta is in radians, we just multiply our formula to 180 over pi. As if we are converting degrees to radians. So in here, we can cancel pi. And 180 and 360 in the numerator and denominator respectively can be expressed in lowest terms as 1 and 2 respectively. So therefore, it can be reduced to theta over 2 times the square of the radius. Let me just emphasize that your technique in choosing which formula you will be using is the degree symbol. If the given has degree symbol, use our first formula, that is for degrees. Otherwise, use the second formula. Let us have an example. The radius of a given circle C is 14 centimeters. If the measure of arc AB is pi over 2, what is the area of sector ACB? So the given sector angle here is in radians. That is pi over 2. Therefore, we use this formula. We have theta over 2 times the square of the radius. So we just substitute our given. Theta is pi over 2 and your radius is 14. So we have pi over 2 over 2 times 14 squared. If we're going to simplify that, we have pi over 4 times 196, and that is equal to 49 pi square centimeters. So our answer here, or the area of sector ACB, is equal to 49 pi square centimeters. Try this. The radius of a given circle is 8 centimeters. What is the area of the sector if the measure of the sector angle is 72 degrees? Let me repeat that. The radius of a given circle is 8 centimeters. What is the area of the sector if the measure of the sector angle is 72 degrees? You may comment your answers. We are looking for the area of the sector. All right, time is up. If you have answered 64 pi over 5 square centimeters, you are correct. You have understood the concept very well. Moving on, for the area of the segment, the derivation part would be left to you as an exercise. Our formula is already flashed on the screen. Now, you will be needing your scientific calculator to be able to solve for this one. So our formula when theta is in radians, we have theta minus sine theta over 2 times the square of the radius. While when theta is in degrees, we have theta times pi over 360 minus sine theta over 2 times the square of the radius. If the given is in degrees, make sure your calculator is set to degrees mode. While if the given is in radians, make sure your calculator is set in radian mode. Again, let me repeat that just to emphasize now because this is very important. If the given is in degrees, make sure your calculator is set to degrees mode. While if your given is in radians, make sure your calculator is set in radian mode. Let's have an example. Circle P has a central angle of 98 degrees with radius 21 feet. Find the area of the shaded segment. So as you can see here, our theta is in degrees. So we use this formula. Then we just substitute your given. Theta is 98 degrees and your radius is 21 feet. So we have 98 pi over 360 minus sine 98 over 2 times 21 squared. Again, make sure your calculator is set to degree mode. And if we're going to calculate that, the value would be approximately 158.79 square feet. So if you have that as your answer, you did a good job. Let's have another example. Circle A has a central angle of pi over 6 with radius 13 centimeters. Find the area of the shaded segment. Again, circle A has a central angle of pi over 6 with radius 13 centimeters. Find the area of the shaded segment. So our theta here is given in radians, that is pi over 6. So we use this formula. And we just substitute the values. Theta is pi over 6 and your radius is 13. So we have this equation. And that is approximately 1.99 square centimeters. So here are some things to remember in this module number 5. Tangent is a line, a segment, or a ray that intersects a circle at exactly one point. Secant is a line, a segment, or a ray that intersects a circle at exactly 2 points. For the area of a sector, When theta is in radians, we use the formula theta over 2 times the square of the radius. While when theta is in degrees, we use the formula theta times pi over 360 times the square of the radius. Now for the area of a segment, when theta is in radians, we use the formula theta minus sine theta over 2 times the square of the radius. And when theta is in degrees, we use theta times pi over 360 minus sine theta over 2 times the square of the radius. Let us now have the frequently asked questions regarding the topic. Our first frequently asked question: what do you call the point where the secant touches the circle? Again, what do you call the point where the secant touches the circle? Well, it does not have a special name. Kumbaga, hindi nabinyagan. Unlike in tangent, where there is a point of tangency, in secant, we only call them points of intersection of the secant. Next frequently asked question: what if the boundaries of the region are a diameter and an arc? So, as you have seen earlier in our example, that can qualify both as a sector and a segment. As I mentioned earlier, it can be a sector because a diameter is composed of two radii. At the same time, it can be a segment because the diameter is your longest chord. Can tangent be a line segment? Yes. Based from our definition earlier, it can be a line segment, or a ray. Same with your secant. The important thing for it to be a tangent is that it should touch your circle at exactly one point. So thank you for those questions. Let us take note that tangent and secant touches the circle at a certain point. We also have tangents and secants in our lives. They touched us and made an impact in our everyday living. They are those people whom we consider special to us, like our family, friends, and so on. They are our tangents and secants. Make sure to pick the right tangent and secant, for they may make or break you as a person. So for your home learning task for this week, please answer the what's more part of module number 5. This has been another Valenzuela live session on Mathematics 10. Once again, I am Sir Neil Raymond K. Factor from Mapulang Lupa National High School, saying that the road that is tangent to the wheel is long and winding. Keep moving forward. See you next week and have a nice day.